This is lesson 2.1a. In this lesson, we're going to start talking about inequalities. So a couple things as some reminders. Here are the symbols we use for inequalities. So less than, greater than, less than or equal to, greater than or equal to. Some key phrases once we get into writing inequalities. This isn't by any means the whole phrase you could ever have or the only phrase, but they're good signals to you of which symbol you would have to use based on those words. And then when we're graphing, whether you would use an open circle, like with these ones that are just greater than or just less than, or a closed circle, like these ones that are less than or equal to, or greater than or equal to. A couple things I remember about open versus closed. If you think about the line at the bottom filling in the circle, they're closed because it also includes the number that we're talking about. Okay. So first we're going to look at example 1. And in example 1, we're going to actually 1, 2, and 3. We're going to be taking the phrase and we're going to be writing an inequality to match the phrase. So we have a number W minus 3.5 is less than or equal to negative 2. So when I see the phrase a number, remember that reminds me of variable. In this case, they actually gave us the variable they wanted us to use. Minus, that tells us we're using subtraction. 3.5 is an important number. Is less than is a signal that we're using an inequality. If you just saw the phrase less than, then it could mean subtraction, but is less than is that signal that we're using an inequality. Oh, and this one says is less than or equal to negative 2. So based on this information, I'm going to have a number W. So we've got W minus 3.5 is less than or equal to, so when I look at these, less than or equal to, so that's this one here, negative 2. And that's all they want us to do. They don't want us to solve anything like that, simply taking the words and putting them into an inequality. So we're going to do the same thing for example 2. 3 is less than the number n plus 5. So 3 is less than a number n plus 5. So this one, I'm starting with 3. Now, is less than, is less than, no line on this one. So it's not or equal to, it just is less than a number, n this time, plus 5. And then we're done with that one. One more time. Let's do example 3. Example 3 says 0 is greater than or equal to twice a number x plus 1. So 0 is greater than or equal to twice. Remember, when we see twice, it means we're multiplying by 2. So twice a number x plus 1. So let's check our signal real quick. Is greater than or equal to? Is greater than or equal to? This one right here with the line. So 0 is greater than or equal to twice, so 2 times our number x plus 1. So that's our inequality for example 3. All right, so the next thing we're going to talk about is whether something is a solution to an inequality or not. So the solution of an inequality is a value or a number or an amount that makes the inequality true. Now, with inequalities that are different than equations is that inequalities can have more than one solution. And in most cases, they have multiple solutions. So oftentimes when you have an inequality that has multiple solutions, it's going to get referred to as the solution set. So there's like a set of numbers, it could be all these numbers that are bigger than this, or all these numbers that are smaller than that. So it gets referred to as a solution set. But basically, if it falls into that category, that set of numbers, then it would be part of the solution or a solution to this inequality. So for example 4, we are trying to decide, is negative 4 a solution to these two inequalities we're going to check? So the first one, x plus 8 is less than negative 3. So in order to check if something is a solution, we can plug it in. So solution means it would get plugged in for the variable. So negative 4 is going to go in for x right here. So negative 4 plus 8 is less than negative 3. Perhaps, we're not sure. So oftentimes you'll see a little question mark right there. So negative 4 plus 8 is 4. Well, is 4 less than negative 3? No. So this is not a solution. Inequality B, we have negative 4.5 x is greater than negative 21. So again, the number we're testing is negative 4. So I'm going to plug that into my inequality here. Negative 4.5 times x, because remember that's what that means. So times negative 4 might not be greater than 21, negative 21. So I put my little question mark there. Negative 4.5 times negative 4 is positive 18. So is positive 18 greater than negative 21? Yes. So it's a solution. Now, if I'd solved this and I got negative 21, is negative 21 greater than negative 21? No, it's equal to, but this symbol does not say or equal to. So be very careful when you're testing solutions to make sure that if it does not have an or equal to and you get the same number, we'd have to say no for that solution, okay? For the next examples, we're going to be graphing. So for example 5, we have the inequality. Y is less than or equal to -3. Now when we graph inequalities, it's always on a number line. My recommendation, when you're hand drawing your own number lines, I generally will put my number that I'm testing here. That's in my inequality. I'll put that in the middle. And I'll go one number above, so closer to 0 is -2, and one number below, farther away would be -4. This also gives me numbers I can test. So if I'm looking at this, first of all, I have less than or equal to. So I go to my chart here, less than or equal to. I know it's a closed circle, and that closed circle goes right on this number here, -3. Then I have to figure out, okay, which direction does my arrow go? Because it's not just -3, it's everything less than, y is less than or equal to -3. So -3 is the largest. So if I plug in -2, is -2 less than or equal to -3? No, it's not. That's bigger. It's closer to 0, right? Then let's test another number, -4. Is -4 less than or equal to -3? It certainly is. So because it is, I shade my arrow towards the side that tested true. So this graph would say that every number smaller than and including -3 would be a solution. Example 6, we have 5/2 is less than x. So this is kind of a tricky one. Sometimes people get mixed up when the number is on the left side. So what I want to show you, just like with equations, we can flip the entire thing around. So I can put x here, and I can put 5/2 over here. But you have to be careful, because in this inequality, 5/2 is the smaller number. So that little alligator, if you remember from elementary school, the alligator's eating the x. It still has to eat the x, even if I flip it. Okay? So the larger side by x, larger side by x. So now this says x is greater than 5/2. So I'm going to put 5/2 on here. If I'm counting fractions, I could do 6/2, which is above, and I could do 4/2, which is below. Some people also will recognize that 5/2 is 2.5, and that 6/2 is 3, and 4/2 is 2. I don't care how you label them. Either way is fine. So we're going to test is, first of all, let's check our circle. Greater than, open circle. So open circle of 5/2. And we're going to test, is 2 greater than 5/2? In other words, 2 greater than 2.5? No. Is 3 greater than 2.5? Certainly is. So we're going to go towards the 3. And then example 7. We have z is greater than or equal to 0. So again, I'm going to put my 0 on here. One above would be 1. One below would be -1. I could do 10s, 5s, whatever I want, but I have to do something above and something below. I have greater than or equal to, so I know it's a closed circle. And it's a closed circle, like I said before, at 0. And then we're going to test. Is -1 greater than or equal to 0? No. Is 1 greater than or equal to 0? It is. So we'll shade everything towards that +1. This is lesson 2.1b. In this lesson, we're going to be looking at graphs of inequalities, and we're going to be writing the inequality for it as well as interpreting what it means. So as we look at this first example, it says, the graph shows the height restriction h in inches for a ride at an amusement park. Write and interpret an inequality that represents the height restriction for the ride. So when we look at this, one thing I want to point out to you is that this circle right here is filled in. So because that circle is filled in, we know that our inequality has to have a line underneath of our symbol. So it's either greater than or equal to, or it's less than or equal to. So first we know that we're dealing with height in inches. So we know our variable is going to be h. We know that our inequality symbol has a line underneath of it because that circle is filled in. And remember that h represents all of the solutions to this inequality. So for starters, 48 is a solution because the circle is filled in. So that's why it's 4 equal to. And now we need to figure out, okay, is it 48 and all the numbers above, or 48 and all the numbers below? So when I look at this, it's filled in darker on the right-hand side here. So what that means is that it's 48 inches and above. So 48 is the smallest height you could be in order to write this right. And it was talking about inches, so we could even label it 48 inches. So when we're interpreting it, the inches are important. When I'm writing my inequality, I don't have to have that label. But when I'm talking about this, I know that in order to ride whatever ride this is, I have to be 48 inches tall or taller in order to ride the ride. So just a reminder of what we were just talking about. For example 2, it says, the graph shows the height restriction h in inches for a ride at a water park. Write and interpret an inequality that represents the height restriction for the ride. So as I'm looking at this one, first thing I'm noticing, our variable is h. Again, talking about height for this one. I'm noticing that the circle is open on my graph, and it's open at 52. So 52 is not a solution to this inequality because that circle is open. It's not including 52. And then I look at my line. This one happens to be traveling to the left, which is all the numbers smaller than 52. So we know that h has to be smaller than 52 inches. So what that means, again, if I'm 52 inches, this time I'm too big for the ride. I have to be less than 52 inches in order to ride this ride. 51 inches, fantastic. 51 and a half, fantastic. 52.0, too tall. So it has to be smaller than 52 inches in order to ride this particular water slide. And I'm sure you've seen these kinds of rides before, right? They're the ones meant for the little kids, so they don't want the big kids on them to break them or to cause problems for little kids. So they just make sure, hey, we've got some rides for just little kids. So you have to be less than 52 inches in order to ride this one. In example 3, it says, let A represent the number of students in band, let B represent the number of students in the school choir. Where B is less than A, interpret the inequality and tell whether it is true. So we know that the number of students that are in band is less than the number of students that are in choir, and that's because of this part right here. B is less than A. So we know that the band students, there are less of them, or sorry, A is band, so the choir students, there are less choir students than there are band students. So when I'm looking at this, a couple things I'm noticing. I know that A plus B is our total number of students in band and choir. So let's jot these things down. Just to kind of sort our thoughts here. So A plus B equals the total students in band and choir. Okay. A couple other things I'm noticing. A plus B divided by 2 is talking about the average number of students in that combination of classes. I'm just abbreviating here. All right, so A plus B divided by 2 is the average of students in both classes. Now, as a result of that, we know from our experience with averages, it means that the number, like the solution to this, if we had the numbers for A and B, we know that the solution would be somewhere between A and B. That's going to be an important piece of information in a little bit. Now, the next fraction that we have over here, A over A plus B, this fraction is relating or comparing A, just the students in choir, to the students in both classes together. I do keep doing that, A band. So it relates the band students to the combination of band and choir. Now, since we know that the students that are only in band are less than the students in the combination of the two classes, we can make a conclusion that A over A plus B is going to be a number that's less than 1. Because essentially, it's like making a fraction. So let's say this is 4 and B is 5, right? We'd have 4 on the top divided by 4 plus 5, which is 9. 4 divided by 9 is going to give us a number that's smaller than 1 because it's a regular fraction. It's not improper or anything like that. So that's how we can make the conclusion that it's going to be less than 1. So if we're looking up here and we see that this number here is between A and B, and then we see down here that this is less than 1, then we can make the decision that A plus B divided by 2 is going to be something that's larger than A over A plus B. So when we're looking at that comparison that we had, right, our original inequality looked like this. So when we look at the information that we've been presented and we kind of analyze what we have, we actually discovered that that's not true. The average is not less than A over A plus B. So this would not be a true inequality. Okay, so for example 4 now, it says, let A represent the number of students in the senior class, let B represent the number of students in the junior class. Where A is less than B, interpret the inequality and tell whether it's true. So A is our senior class, and B is our junior class. Now hopefully I won't forget this time, which is which. So just like we did with example 3, we're going to kind of analyze the information that we have. So the first thing I'm looking at is, on this side here, I have 2B. And remember that 2B equals B plus B. We also know, right here, A is less than B. So if we look at it that way, so B plus B is definitely going to be larger than A plus B. So A plus B is going to be smaller than B plus B, since we know right off the bat that A is already bigger. So if we've got 2 of these that are already bigger than this is, then I know that 2 of them is going to be bigger than A and B combined together. So as a result, if I look back at my original inequality, A plus B less than 2B, we know that that one is true. That one had a little bit less analyzing for that. A little bit more straightforward for that one. This is lesson 2.2. In lesson 2.2, we're going to continue talking about inequalities. And this time, when we're talking about inequalities, we're actually going to talk about solving them. And the great thing about solving inequalities in this lesson is that it's very similar to what we were doing when we were solving equations in our previous chapter. And when we're solving inequalities, the only difference really between solving this inequality versus solving an equation is that the symbol in between, instead of an equal sign, is a greater than, a less than, a greater than or equal to, or less than or equal to. So it's just that symbol in the middle at the moment that changes from an equation to an inequality. So if we take a look at our first example, 0.07 is less than or equal to negative 4.05 plus z. So just like in our equation, our goal is to get this variable z all by itself. So just like we've done in the past, if my goal is to get z by itself, I have to undo the addition or subtraction on the variable side. So when I look at the variable side, I have negative 4.05. In order to make that 0, I have to add 4.05 to both sides. So those are going to cancel to make 0. Bring down my z, because I haven't used it yet. I'm going to copy this inequality symbol here, because again, I haven't used it. I haven't done anything with it, just like the equal sign. 0.07 plus 4.05 is 4.12. And a lot of times, like we've talked about before, it's a lot easier to read and understand an inequality when the variable's on the left. So I'm going to take the whole inequality, and I'm going to flip it around. So z, now the alligator is eating the z, so it still has to eat the z. So now it's kind of flip directions a little bit. And then that 4.12. So z is greater than or equal to 4.12. Now if I'm going to graph this on my number line, put 4.12 in the middle, and we'll call this 4.14, and we'll go down and we'll call that 4.10. So keeping my spacing the same. This is an or equal to, so I know that it's going to be a closed circle here at 4.12. And it's z is everything greater than or equal to that 4.12. And I want to show you something that I haven't told you yet. When the variable's on the left-hand side, notice that your inequality symbol kind of acts like an arrow. See how it follows that same path on my graph? It's only true when the variable's on the left-hand side. But if you have the variable on the left, you can use this inequality symbol to kind of point you in the direction that your graph needs to go. Now, when it was backwards, it was a little bit confusing. We couldn't use it that way. But when the letter's on the left, we can use that arrow to follow for our graph. So for example 2, we have 5/6 is greater than x plus 2/3. So again, my goal is to get x all by itself. So for this one, I'm going to undo the addition, because this 2/3 has a positive in front of it. So I'm going to subtract 2/3 on both sides. Now, since it's fractions, these will cancel. So I can bring down my x. But on the left side over here, we've got different denominators. So I'm going to slide over to the side here. 5/6 minus 2/3. I need a common denominator. Common denominator for 6 and 3 is 6. So I'll multiply the top and the bottom of this fraction by 2. So I have 5/6 minus 4/6, which gives us our answer of 1/6. So over here, I have my 1/6. Carry down my inequality symbol. Again, this time my variable's on the right side again. So I'm going to flip it. Everything just switched sides. It doesn't make this wrong, but when I have to graph it, it just makes it easier if my variable's on the left. So I draw out my number line here. 1/6. So I'll go down to 0, and I'll go up to 2/6. Sure, I could reduce it to 1/3, but since I'm already looking at sixths, sometimes it's a little bit easier if my number line is written the same way as well. All right, so for this one, we have no lines. We've got an open circle at 1/6, and x is smaller than 1/6. So everything to the left. All right, let's take a look at example 3. We've got a circuit overloads at 1800 watts of electricity. You plug an amplifier that uses 900 watts of electricity into the circuit. In addition to the amplifier, which of the following equipment can you plug into the circuit at the same time without overloading the circuit? Now that's really important because the maximum load that this circuit can hold is 1800 watts. So that's going to be important for our inequality. That's at that point, it overloads. So we got 1800. And since it's going to overload at 1800, it cannot include 1800. So we have to be less than 1800. That's the maximum. We know that we have 900 watts of electricity for our amplifier, so we have to include that. But we also want to be able to plug in something else, right? So we're looking for other equipment that we can do. We need to know how many watts we have available to be able to use. So in addition to this 900, we're going to add some unknown number of watts. So we use W for watts. So we have our inequality. Now I'm going to solve. Again, goal to get W by itself. So I'm going to undo my addition by subtracting. 900 minus 900 is 0. Bring down our W. 1800 minus 900 is 900. So we have to look at wattage that is less than 900. So if I'm looking at this table, I can make some combinations. But fog machine 1 is 450. Fog machine 2 is 450. I can't plug in 2 fog machines with this amplifier because that's 900. And the circuit will overload if we get to 1800. So those two combined for 900 with the 900 we already had would overload the circuit. I can use a fog machine and a television, for example, because that's only 650. I could do my lighting and my television because that's only 800. I could do one fog machine if I wanted, just a fog machine. But any combination of these other pieces of equipment, as long as it is less than 900 watts. Because like I said, if we get to that 900 watts combined with our 900 watt amplifier, then it's going to overload our circuit.